right, let's get going. So welcome everyone to this webinar on Qumulo Trends, the Qumulo Trends service. I'm joined today by Juan Ulloa, who is part of a UX team and might have some cool info about the upcoming future state of self-monitoring that we can talk a little bit later down in this presentation. And I have Billy Hatcher also with me from our customer success team. My name is Joe Costa, I'm Solutions Architect. You can reach me directly at joe@qumulo.com or via Slack if you have any questions. The format of this webinar is interactive, so feel free to play along. If you see here on my screen, I'm signed into trends.qumulo.com. You can feel free to play along with your own clusters on here. If you have any questions, we have a Q&A panel. You can pop in a question and Billy will keep an eye on it and ask questions throughout. And hopefully we should have enough time at the end for a nice Q&A session to answer whatever questions you may have. So let's get started here. So what is Qumulo Trends? Qumulo Trends is a service provided to you by Qumulo, where the data that comes from your clusters, if you opt in to turn on the Qumulo Care cloud-based monitoring, if you turn this on your clusters at home, quite a bit of information comes from your clusters to Qumulo, and we take a subset of this information and we present a digest of a certain period interval to you to help you keep an eye on the overall state and health of your cluster. So if you're not familiar with cloud-based monitoring, this is all the technical data of your cluster, latencies and temperatures and overall health of your cluster. There is no user identifiable information that gets sent back to Qumulo. So all this information won't have any usernames, any paths, anything like that. You just get all the sort of anonymous performance and health data that gets sent. There's quite a bit of information that gets sent back to Qumulo. So you flip this on, you have your cluster then goes up to Trends. So if you go over here to Trends, you would log in with your Qumulo single sign-on account. If you currently don't have a Qumulo single sign-on account, contact your customer success manager and we'll get you set up for that. But this is the same account that you would use to sign in to Care. For example, if you go to care.qumulo.com and file a ticket, it is exactly the same account. So in this case, I'm going to pop in and sign in to Trends. And once I'm in Trends, I have visibility to the clusters that have been assigned to me. Now, this over here is in the home page. I have my 3 Qumulo engineering clusters, and our customer IHME was gracious enough to allow us to present data from one of their clusters that has some really cool use patterns, so I can show you a more realistic view of a cluster out in the field. Thanks, Sarkhan. So you get to pick which clusters are visible here by going into your settings tab. So for customers that have multiple clusters, perhaps you don't want to show them on this homepage all the time. You can go over here to settings, and I have a mock-up what that looks like over here. You'd see all the clusters that are assigned to your account. And you can do a couple of things. You can choose which ones show up on the home page by clicking the little checkbox and then just hitting the home button again. And you can also receive email alerts for Qumulo events that get reported to Trends. And we'll talk about Qumulo events in a bit here. But if you check this box, then anytime the new Qumulo event pops up, you will get an email on whatever email account is assigned to your Qumulo account. So let's dive in, shall we? So the first view here, you have your kind of generic sort of about view here. This tells you a little bit of information about Trends. pretty generic. But one thing that's pretty cool about Trends is that once you're logged in, you have access to the Downloads tab, where you have every single Qumulo release that is in current support, down to some pretty archaic ones in the 2s over here. So if you want a quick and dirty way to get a software update image, you just pop into Trends, go over to Downloads, and then click on your core release. You can also review the notes for old releases. This is a kind of handy way to do this. You have a quick sort of reminder of which ones are the quarterly updates by the Q little symbol right there. But yeah, you can just drag an image, you can just save it directly to your Qumulo cluster for updates. So in the homepage, you have just a generic overall view that tells you the use capacity of your cluster. And you have 3 different sections here of interest. So the first one that we're going to spend some time on is the time series graphs, and it's probably the one that you would spend the most time looking at. So time series graphs is exactly what it sounds like. It shows you some information laid out over a period of time. In this case, the period of time is managed by this block right up here at the top of the screen. So I can set a start date and an end date. Now, I think that's important to remember, or I think it's important to know about Trends, is that the data that is collected from your cluster, sent back to Qumulo, processed for presentation, and sent to Trends. This data is presented to you in a 15-minute sort of resolution. So each block of time here is a 15-minute interval that presents a digest of that data. So you can pick a range of time to display up here, and you will have 15 minutes for each divider up here. Now, certain bits of data and certain patterns that you're looking for, they are better suited for smaller periods of time. Like if you go between a day and another day, you get a certain kind of use pattern, or maybe some things stand out a little bit more, while perhaps other views looking at 30 days might make more sense. And we'll go into some examples in a bit here. So there's a couple of date shortcuts just to save you some time typing here. So I can just click on the last 24 hours. Sometimes you need to hit the update graphs if you're picking a specific time here, but I have the last 24 hours, and you see this kind of dead time over here because, well, we're not in the future yet. So 8 a.m. is coming. I can do last week, last month. In this case, I'm going to do, let's do this last week and see what this cluster looked like last week over here. And I'm going to change this date to be the 27th, simply because I don't want any dead time at the end of my graph. I'm going to hit update graph right there. So Qumulo currently stores 30 days of this information. So you should be able to reliably go back 30 days and get this info. There's up in the capacity, the storage is actually quite a bit longer, but for the cluster timelines here, we're looking at about 30 days. So the first graph, actually, before I get down into the graphs, it's kind of helpful to notice that I have a little question mark on each one of these, and we have a pretty well-written help guide that gives you an overview of our logic and what we presented here and what data is there. If you want a kind of quick recap beyond this training session here, you can just click on that little question mark, and we'll give you an idea of how we decided to present that data to help you understand that data a little bit better. So I have a number of different graphs that has quite a bit of different information in here. The thing to keep in mind when dealing with trends and using trends as a tool to help you understand more about your clusters is that trends, all this information that we present to you is meant to be taken as a whole, to be used together. So these graphs all work together to help you understand why perhaps there was a spike in latency on your cluster, or why did some kind of event happen. You have to take these all as a whole. It's probably not super useful to really kind of drill down and focus only on one graph. You have to look at the whole thing as a whole, including events that happen and latency graphs that we will cover a little bit later. So first stop on our graphs is our capacity. It's pretty straightforward, right? So we're looking at the overall used cluster capacity, how much data is used on this cluster. You get a pretty generic view, just like you would see on your homepage when you log into the UI or your Qumulo. For clusters that have a small files, and a small file will be something that's 100K and less in percentage in relation to the overall file count, you'll see the metadata capacity going up. And interesting bit here that's important to know is that this little guy can be moved around to get out of your way, and you can turn on and off different elements of the graph. This becomes important in some of the upcoming graphs here. So the next one is your file counts. So that was pretty cool to see a cluster go over 1 billion files. You get to kind of get an idea of the file growth over this week. I guess this would be sort of a useful thing to do, because sometimes the actual file counts are more important than the actual capacity in bytes. In this case, you can just very casually kind of scrub through here and see if you have sort of an abnormal growth or decrease in files. Now we start getting into the meat of the data here, which is the read and write throughput. So the read and write throughput, again, we have to remember, this is a 15-minute interval at any time, and this is the coalesced view of what happened on average on that 15-minute period. So if I take a look over here and I see that I have a spike, and I'm reading data at 37 gigabytes per second on this cluster, I need to kind of see, okay, so is this abnormal? Is this normal? Is just something that happens on my cluster on a regular basis? And this is an example where turning on and off graphs becomes important, because the default view is to have these two guys on the bottom turned off. Now, these two are quite important for forecasting purposes. This is the reclaim delete rate, which is how fast is Qumulo deleting data. When you trigger a large delete behind the scenes, you have the delete is an operation that's not free. It's basically like a reverse of a write, and that consumes some capacity of the cluster. And then I have the reclaim snapshot rate, which is when your snapshots expire. That itself is a delete operation that has an impact on the overall performance. So in this case, you see right there at that peak at 8:45, I was deleting snapshots at 15 gigabytes a second. So this is a non-trivial amount of work that the cluster was doing at this particular time. So you can make sure that when you pop into your own graphs that you turn these guys on and off to get an idea of what's going on in your cluster. So down to the next one, we're looking at the overall IOPS. Again, this is all on the name of looking at trends as a whole, just like the name of the site here, to see if something looks out of the ordinary. Is there any kind of pattern that it's not what I expected to be here? So in this case, if you just look at the IOPS, 1 million IOPS tends to be the normal historical peak for this particular cluster. So that's the kind of, I've not seen anything that's outside of the norm on here, and the peaks tend to be, in the 30 gigabytes a second for this cluster. So now the next graph is kind of an interesting one. This is where you start to look into the actual capabilities of your cluster. And for this one, I'm going to go back into the week view. And disk utilization percentage, I have two different graphs here. So this will be a single graph. if you have a all-flash cluster, but with the hybrid clusters, we have a layer of HDD, we have a layer of SSD. And this gives us information that we are retrieving from the Linux kernel that gives me a estimate of the total overall available capacity of my disk layers. So as I get into some of these peaks here, I see that I'm using about 96% of the overall capacity of at least one of the nodes in my cluster for the SSDs. If you find yourself continuously pegging any of these layers, especially the HDD layer, because it's a lot more latency sensitive, it's actually very good to have high SSD utilization, because it means that a lot of your data is on cache. You're caching that data and you're being very efficient about using your SSD cache. But if your HDD utilization is very high, it's probably a sign that the cluster is oversubscribed, possibly, or in an extreme case, I would even say that maybe it's the wrong node type or the cluster type for the workflow. So a good example would have been that if I'm continuously pegged and my HDD utilization is very high all the time, and then I take a look at my used cluster capacity and I notice that my metadata averages is very high, because the metadata obviously is the information of the data about the data, which is the file attributes, the file permissions, the directory extents where all the stuff lives on disk. All that gets stored in the metadata. And anytime you create a file on a file system, you also generate a little piece of metadata. But the smaller the files are, the larger the metadata was seen in relation. So if I had a cluster that had 10 billion tiny files, I would see a graph that would have, very high metadata usage in relation to the data usage. And if I ended up seeing that my hard disk was continuously being used all the time, I could make the correlation that I am actually storing metadata on HDD, which is a bad use pattern. So for clusters that have billions and billions of tiny files, like 10K, 4K files, those clusters really should be all flash clusters and not HDD. But this is something that you see. So that's an extreme example of understanding HDD utilization as a whole here. So high SSD utilization is good if I'm not pegging it, because it means that I'm using my cache. And that's why we pay the premium for those SSDs. So this is a good thing. High HDD utilization is almost never a good thing. CPU utilization is really kind of pointless on its own, because there's not a whole lot you can do as an end user to influence this number, other than perhaps not enabling SMB3 encryption, because the SMB3 encryption on the wire is something that will use more CPU. But overall, as an administrator, you really can't influence this number much beyond that, with the exception that you want to keep a look at spikes to see if something else is going on in your cluster. So in this case, I have a spike over here that happened at 5:15 at 10:22. What else was I doing at 5:15 at 10:22? Maybe I was deleting a lot of snapshots. So I have a combination here. It is interesting. 5:15. I was reading data at 35 gigabytes a second. And I was also deleting snapshots. You see the snapshot reclaim rate right there at a pretty good clip. And I also had quite a bit of writes going on at the same time. So necessarily you'd see that the cluster was just busier at that time. So this kind of makes sense. All these go with each other. It's very easy to understand why the CPU was peaking a little bit over here. So again, all these graphs are meant to be taken in two ways. You have a broad view, a macro view of your cluster. You really are not going to drill down 100% on with a 15-minute interval, but will give you a really good idea of the overall sort of activity that the cluster was experiencing. And these graphs then also go together. You have to look at them together to kind of understand. And it's useful to kind of keep that timestamp in mind as you go up and down between these graphs. So you saw that during that peak, I still had plenty of HDD capacity, but so I actually used up a little bit of HDD over here. And I think that has to do because I was deleting data. You know, if we ever had a conversation about how we cache data and how we expire data to HDD on a hybrid clusters, you know that eventually, given enough time, every bit of data on your cluster will end up on HDD. If you know, and then that data, when you delete it, you're deleting it from HDD. So you're making these drives do a little bit more work than they normally would have. So now we go down to the read and write latency graph here. And again, this is a macro view, a 15-minute sort of conglomeration of all the different protocol latencies that we can get a little bit more detail in another view. But this is like a rough sort of overall estimate of the whole. So the real use of this particular graph is to see something that falls outside of the pattern. So if my pattern for this week is a certain thing, or I can actually go back to last week, you know, I'm doing exactly the same work. Let's say that last week, this cluster processed exactly the same type of data, servicing exactly the same type of applications. But then this week, I have some notes from my user base that says, hey, this job took longer. What gives? I can take a look at my latency graph and I can see, well, you know, last week, you know, my peaks were in the tens, whatever that means in here, of milliseconds. Now I'm sitting on the 1 second range. What's going on? So this is kind of like looking at peaks, just like for your audio guys out there, if you have your equalizers that have the little peaks that would sit, you know, as your EQ and your music is playing, you have the little peaks that sit and tells you just how high you got. That's kind of the way to look at this thing. It's really not going to drill down and fine tune the actual latency. We can do that better on the next tab over that will show you. But this shows you that, yes, that was a big spike right there. What was going on? Let's take a look at the rest of this information to see if we can figure out exactly what was going on here. And then metadata latency, this is specific to the metadata that we talked about. You will see this go through the roof if you are following yourself, if you're in a scenario where you have metadata that is landing on HDD. And the way you find yourself in a scenario is because you have massive file counts and just not enough SSD on your Qumulo cluster to pin that metadata to. And that's really kind of a cluster sizing scenario. This is a good idea to see if perhaps these are the wrong node types, or perhaps I need to add more nodes to handle my massive file counts. Really, usually not a problem on most clusters that have been sized properly. And then we have clients reading and writing. This is an overview of 15 minutes. In that 15-minute period, I had 259 clients reading files, 246 clients writing files. So this is coming from your connection counts on your cluster. Again, taken as a whole with the rest of these graphs, if I wanted to see that there was some kind of unusual pattern, all of a sudden I have way more clients connected than I'm used to. But in this case, I see that I have my normal sort of median sitting over here around 200 or so. If all of a sudden there was a spike of 1,000, perhaps I should be concerned and start taking a look to see, why did I have 1,000 connections? Why did I have 3,000 connections to my cluster? So files being written and read, again, this is to be taken as a whole. I kind of get an idea how many files were open. If all of a sudden my 15-minute averages show a massive spike, perhaps I could have a security issue going on, or there's something else going on. Why do I have that many more open files than I normally would? And then the data read and write size. This graph is always going to peak at 1 million. This is 1 million bytes, so 1 megabyte. this is the read and write size as negotiated by the protocol. So the SMB protocol, the NFS protocol, a perfect quote unquote packet has 1 megabyte of data. That's the max that a file, when you take a 100 megabyte file and you transfer it over SMB, a perfect SMB transaction to write or read a 100 megabyte file would be 100 1 megabyte packets, because that is the most that can be sent per packet for that file. Same thing with NFS. So looking at this graph, if anything, would tell you that I am dealing with lots of small files, tiny little files. Take, let's say that an NFS operation takes three TCP packets to complete, to copy 1 megabyte with 3 TCP packets. But if I have to copy a 4K file, I still have to use the same 3 TCP packets. So this kind of just gives you an overview of am I getting that great throughput because I'm sending these big fat packets, or am I dropping in throughput because my clients all of a sudden start asking for tiny little files? This is not something that you can influence as an administrator most of the time, but you can keep an eye to see, why did my performance drop? Well, you're reading a whole bunch of tiny files. That's just the way it was. That's what this graph is telling me. So this is kind of, again, taken as a whole, this adds another clue to the puzzle for you to understand what's going on in your cluster. So next graph is kind of for your own benefit over here. This guy has the system temps. You definitely want to take a look at this historically here. So let me do a last month, because that's kind of the way to look at this guy. Let it update here for a second. So I'm going to go down here to this. I want to see a nice steady line. I don't want to see any outliers. If all of a sudden I see that one of my nodes, again, I can turn off all the nodes I don't want to see if I want to isolate just one. If all of a sudden one of my nodes by itself is sitting over here at a higher temperature, perhaps somebody left a blank panel off the rack. Maybe the airflow to that node is being blocked somehow. Maybe there's a bad fan inside of the node itself. But if I see a upward rising trend of the entire cluster, then that's definitely something going on with my air conditioning. And it's several times in the past, customer success has been the notification for several of our customers that their air conditioning had broken, because we started getting temperature alerts, and we had to take them down to the data center to start turning things off. But that's the system temperature here. So now we have node connection counts. This is kind of an interesting one here. So this is node work balance or load balance. That's what this graph is. So node load balance right there. And this is kind of an interesting one, because we have to kind of understand what data is being presented here. So we have a combination of client counts per node and where the latency or the information that we presented above, where is that information coming from? So what you want is not to have one of the nodes doing all the work. You want to have, so in this case, if anything I can take out of this particular view, I can see that node 13 in this cluster tends to always be doing a bunch of work. Not necessarily a bad thing if it's not the only node doing a bunch of work. But what I don't want to see is that I have one of my nodes that's doing all the work and the rest of them are idle. Now, when you're dealing with connection counts and client connection balance, it's kind of tricky, because I can have a 4-node cluster and 40 clients, and I can have 10 clients per node, but there's no guarantee past that point that each one of those 10 clients are going to be doing exactly the same amount of work all the time, right? So, but you want to make sure that this graph is nice and sort of even, in every node at any given time is doing some amount of work. So, but in this case here, because I am looking at a month's worth of data, my resolution drops to 30 minutes. So if I am really concerned what was going on over here on this date, then I want to fine tune my view. I want to go back up to the top over here and change it to the last 24 hours or whatever, if I believe that this is an abnormal pattern. Now, at the top over here, you see I have a quick switch for me to take a look at another cluster. So let me pop into Gravy Train, which is inside of the Qumulo offices. This is the cluster that we build all our code against. You guys, if you set some of our demos, this name might be familiar here. I can pop open, I can see, there's actually a peak right in here. And I can kind of take a look at the last graphs over here where I have my network throughput in and out. Do I need to see any kind of outlier? So this is a little bit of an outlier here. What was going on? So node 2 was doing a little bit of extra work. If I think that this is a concerning development here, I can always scroll up and down and see, what else was going on. Was this cluster servicing more clients? So this is at 2 p.m. on 10/14. I can see that I can almost guarantee that node 4 was the one that was servicing that read and write pattern right there. And but looking at the right workload is fine. So this is kind of, again, these two graphs are really more useful to be taken as a whole with the rest of the information in the graph. So I would not really lose a lot of brain cycles, just hunting down why there's a peak here. In this case, there's a peak because the rest of the cluster is pretty idle and somebody decided to read a bunch of data. That's what that peak means. It doesn't mean it's an abnormal pattern. So let's pop into Venus FS again. And let's take a look at some of the other graphs here. So the next set of data that we present is capacity. And capacity is pretty cool because this graph can show you up to a year's worth of information. And what this does is that it shows you your use patterns and consumption patterns, and then it shows you an estimate based on some of the data here. You can actually kind of, if you click on help for the capacity page, you can see the logic that we use to present 80 percentile, 50th, 20th percentile to display this data. You can kind of read that and kind of get an idea where the high, median, and low. But this will give you a pretty good estimate that if things don't change, you don't delete stuff, you continue writing at this rate, you are going to run out of space probably around December 29, just in time for New Year's and be called home from vacation. So this is kind of where this view comes in. Again, you can kind of have your entire year on display, and that's kind of, this is a pretty wide range you can have. You got about, a year. We show 6 months by default. So the next graph is latency that I'm going to show you here. Now the latency one, it's a bit of an eye chart, but it's got a lot of good information in here. So what this is showing you, again, in normally 15-minute intervals, how many protocol operations, which are these guys here on the side, how many protocol operations were serviced in this 15-minute period, and what the average overall latency of those operations were. So if you take a look at the help for the latency and ops page, you would see that the average latency is the blue line and the operation count is the green line. So taking this into account, we see that the latency is the blue line going up and down, and the op count is going left and right. So this tells me here that in this 15-minute period at 8 p.m., from 8 p.m. until 8:15, I had 687,000 NFS writes, and the average latency for those 687 operations overall was 22 milliseconds. So that's what that means. So NFS reads or 0.8 milliseconds with 1.2 million operations happen. So this kind of shows you all the stuff, but some of these numbers get pretty small and kind of hard to read. And the reason for this is that the default view of this graph is to take all of these operations and make them relative to each other. So if you check the box that says normalized by op type, then each protocol op is independent of the one above and below it, and they become relative to just each other and not the whole here, which makes things like SMB session setup and things like that easier to read. So these protocol types and what these operations are really useful when using conjunction with your custom success engineer, because those guys have a lot of knowledge of what the behind the scenes meaning of these guys here, what they are. Some of these might be familiar for you guys, like RDR plus, which my prefetching directory listings for presentation with LS. How often am I doing this? If I have a big spike of those operations, then I have an end user that is listing directories a lot. All of a sudden I have no requests or very few requests to list an entire directory, but all of a sudden I have a big spike of this. Is that something abnormal or not? Again, taken as a whole. And this guy is a little bit different when it comes to choosing where to focus on, because we have the graph here, we have the latency in the blue line, we have the op count in the green line. So here's the latency. Is there a spike in latency? Is there some peak in operations? So I see a peak in operations over here. I am going to focus on this guy and see, is this something unusual? The most operations I've serviced were up here. Is this something that's outside of my pattern? Yeah, so I can take a look and I see that, it's not necessarily any different. So 95 million NFS reads and so on. So again, this is great for taking those comments from your user base that says, hey, this job took longer. What gives? And he says, okay, can you tell me when that happened? Well, that happened at 10:22 at 6:45 p.m. Luckily, you'd be very lucky if your end user can tell you that kind of accuracy. But if they can't, they say, yes, I triggered a job at this time and it took longer than he took yesterday. Then, okay, great. Let me see if yesterday the cluster was doing any or less work than it was doing when you experienced the latency. Now, if you notice that the cluster was just plain busier because I was deleting a bunch of snapshots, I was deleting a bunch of data, I had many more clients, and all of a sudden I had a client that was reading data very, very fast, and I'm actually servicing more protocol operations than I normally do, then the answer would be, well, it took longer because the cluster was busier. My car was slower because the hill was steeper. So that's that type of stuff. Now, let's say that everything looks the same. And well, it's the same number of operations that happened yesterday, the same amount of users are connected. I wasn't deleting any more snapshots. What else could have been happening here? This was where then we went to take a look at the events. Now, the events, not a whole lot happened in this guy. So let me go over to Gravy Train. And let's see, maybe something might have been happening here. So let me go back and show you a month's worth on this guy. And maybe some more data. So there's some events here. And these will be the events that we talked about when you can actually subscribe to email events. The events will be anytime something pops on this log over here, you get an email. So in this case, you see that we have an upgrade that was triggered and then a shutdown cluster. This is because perhaps this is a platform update where Linux had to be updated, or that's just a message that you'll see when a cluster actually gets shut down. In this case, actually, when we stop the QFSD process, that's really what this means. Not that the hardware is shut down. So I need to rephrase this a bit. Quorum abandon is when the nodes in the cluster realize that the state of things has changed and they need to drop and reform quorum to ensure that all your data is safe. This is why we have quorum events. Quorum events is all about guaranteeing to our absolute best capabilities that the integrity of all the data and all the operations in flight is as good as it can be. This is why we have quorum events. So we have quorum events when we lose a drive, because what happened to that data on that drive? What happened to the writes that are being committed to that drive? Do we need to recommit? Is everything safe? Everything that Qumulo does is all about the safety of your data. This is why we have these quorum abandonment successes and all these events. But in this case, I'm doing an update. I have to turn off QFSD, the QFSD process that runs Qumulo on top of Linux. And then the nodes agree that we have to abandon quorum. And then they agree a couple of seconds later that, actually less than a second later, that we have to reform quorum. And now we are running a different version. Now, this might look a little confusing for you guys, but you got to kind of remember that this is a Qumulo engineering cluster that gets that runs a lot of non-release software. So for this guy, we updated it from this version to this version. So this is what happened here. Now, if we go back to a hypothetical scenario with our customer that said that things took longer, what if they took longer because we trigger an update right in the middle of their job? So, I mean, this is kind of a tally here on a record that, well, yeah, sorry, we updated the cluster while you're doing your work. Our bad. You know, so, but other events here, if you drop a drive, I think if I go back in time long enough here, I might end up showing you where we had a block error or something here. This guy is not super exciting in events. Let me see. There you go. So here's a block device error. So this is the QFSD system detected that one of the drives was null. It could be node 4, drive 21. You know what? I don't like the way that drive is behaving. So let's abandon quorum because we cannot trust the state of that drive. Did we commit any operations to that drive while the drive was unhealthy? Do we need to recommit those operations? Is the data, do we need to check, verify the validity and the health of that data? So that's kind of, this is telling us that, and that process took about 2 seconds for us to sort out. Actually, it took about a minute. I take that back. So this is what these messages are. This is information that you can subscribe by checking the email alerts. So if you flip the switch here and all of a sudden you get an alert from Qumulo, you got to realize it might not be coming from customer success, but might be coming from your cluster directly. So it'd be something to keep an eye on, because the format of the message would be slightly different than what you get from CS. So let's go back here. So in this case, we've taken a look at everything. We took a look at time series, took a look at events and latency. I know I gave you some hypothetical scenarios, like in this case, am I scheduling my snapshots efficiently? Well, if I take a look at my, let me go back to Venus FS because it's a lot more interesting. And let me take a look at my work week here. I'm actually going to put from, I'm going to put it from Sunday. Actually, we do that last week. I'm going to go from last week, Sunday to Saturday. So I see that I'm deleting a lot of snapshots. This guy here. I'm deleting a lot of snapshots at certain times of day. Are these snapshot deletes, are they causing a corresponding spike in latency? Is there a spike in latency that matches my deletion of my snapshots? Am I dropping my throughput? Am I hurting the performance of my cluster when these snapshots get deleted? Should perhaps I not combine the deletion of those snapshots with the deletion of data that just happens as part of my application's workflow? So my applications themselves could be deleting data. Do I have maybe an input where I can shift the schedule of when my snapshots expire for them not to coincide when my my applications tend to delete data. Sometimes you don't really have a choice, but at the very least, you can kind of keep an eye on it. Maybe you want to delete data on the weekends. Maybe you want to delete snapshots on the weekends. In some cases, like this particular cluster, this guy is busy most of the time. There's always something going on in here. So a weekend doesn't really mean anything to this cluster, but you can kind of take this info as a whole. And one of the other scenarios is, are my clusters oversubscribed? So oversubscribed, indications of oversubscription would be that my HDD utilization is always high, always high. My SSD utilization is always pegged, and I noticed that I have a growing from historically, from when I look over time, my use patterns, if you end up kind of taking a look at this information and maybe recording some of this, you'd see that the type of client counts I started to see have gone up. My end users are starting to throw more work on this cluster. Do I need to add more nodes to alleviate the needs of the cluster, to make it more performant, to give it more space? And this is something that you can work in conjunction with your SE and your customer success folks, and they can take a look at this graph with you and kind of help you understand that, yeah, perhaps it's time to get another node and make the cluster a little bit more performant. And then how much extra capacity do I have? Not just how much extra space do I have to put stuff, but I can see that, as I throw more work, that my read and write latency hasn't gone up. I asked my customers, I told my end users, go ahead and run that job against the Qumulo, and I kept an eye on this graph, then everything kind of set where it was sitting before. I wasn't really pegging anything any more than I was the week before they started to throw that work on here. Then I think I can throw more work on there. But if I had a significant increase in any of these metrics, then again, perhaps I need to start considering getting another node added to the cluster, or however many will fit my needs for how much extra work my end users are asking me to do. So that's kind of how you can use trends as a forecasting tool, not just for when you're going to run out of space, but when you're going to run out of performance in that sense. So you got to keep an eye on what the state of the world looked like before and what it looked after you threw some work at it. And do we have some questions, Billy?
Yeah. Hey, Joe. Thanks for going over this material. It's been great. I even learned something in the Dragon the Legend. I didn't know you could do that, so that's really cool. There's been times where I was
this
like,
thing out of the way. Yeah.
yeah. So that's great that I'm learning things as we go. But we've got a question, which we were talking about some utilization already, but the question is, are there any thresholds for utilization or latency, et cetera, that we should pay attention to?
Well, the thresholds, I would pay attention to anything that is wildly outside of the norm. So this is where taking a look at a macro view, like you look at a month. If I have a month's worth of data here, and let's say that I took a look at the latency graph down here. So there's a spike right there. I can see, is this something for me to be concerned? So the write latency went up a bit, right? That's considered pretty high latency right there. I would have to then kind of fine tune on this day to see really, was the cluster just busier, or was there something else going on? And did that latency then stay long? So a spike of latency could be just a transient event. Now, if the latency then remains high, that's when it's a concern. It's not, it's just the thing to take a look at is that outside of the norm, and then is it staying high? That's then where behind the scenes, Qumulo Engineering has a lot of tools and a lot of extra information that we can flip switches inside of your cluster that will collect a lot more detailed information than even what we get on the end where we can run what's called a trigger that gets really highly detailed latency information for a very brief amount of time, where then our engineers can kind of take a look and see exactly what's going on. But what would trigger worry on your part is because not only did you have a peak, but it stayed high for a certain amount of time. So the temperature, can we set email alert if it goes over a set threshold? Currently you cannot, unfortunately, but we do have one with us that can kind of give you a little bit of a glimpse into what is coming and what's coming next after trends. Because one of the things that we can also do in trends today is that we can't really add custom graphs for your own information that you're interested in. But one can give you a little bit more information and give you a sneak peek of what the future of monitoring on Qumulo will look like, and how you would be able to also do self-monitoring, where you will be in charge of this information and you will be able to store it for as long as you want. So Juan, I don't know if you want to pop in and.
Sure, I can hop in. Can I turn on video? I don't know if video.
Yeah,
No,
totally. Let me stop sharing.
Oh no, I'm not going to share. So it's okay. I don't really think have anything exactly to share, but I don't think I can turn on video. Anyways, so hi everybody. My name is Juan Ulloa. Good morning and good evening, depending on what time zone you're in. There's a couple of things that we're working on. One of them, and some of you may have heard about this. We've been working on our metrics API, which is a way for us to use an API layer to pull data from the cluster. And the things that are coming soon associated with the metrics API is to have a package in GitHub that allows you to deploy a Prometheus Grafana package that's preset to pull data directly from your Qumulo cluster, display it in a Grafana dashboard that has a lot of this data in here. You could always tweak, because it's using the metrics API, you can tweak the amount of time you want to pull that data. So right now in trends, you're seeing 15-minute points in time, and you could speed it up to 5 minutes, 1 minute, or more if you want. And you can keep that data for as long as you want to keep that data. So in most of the data points that you have in trends, not all, but most of the data points that you have in trends are things that have been ported over or are being ported over to metrics API. So you'll have access to that data for as long as you want to keep storing it in Grafana. So that's coming up soon, and some of you may have been in kind of early customer adoption setups where you might be testing out our metrics API, and some of you may not. The other thing that we're working on, which is coming in the next few months, is that we're revamping how the trends works. We'll have essentially a different platform that we're building. A lot of the data visualizations that you see here will be similar in the new tool. It'll be quite a bit more performant, and you'll start noticing that you'll have the ability to enable not just data visualizations, analytics and metrics on the product, but over time you might start noticing that you'll have ability to take action on clusters, essentially a single pane of glass of visibility and management. So those are things that are coming. And this didn't quite answer the original question about the cluster temperature. But at some point, I can imagine a point where we'll be able to let you know when there's like a warning state of that cluster temperature, so it could trigger an alert, trigger some type of message that gets to you. In the short run, with the metrics API Grafana Prometheus package, you should be able to set a little trigger within that space. You might want to reach out to your CSM to try to figure out what point that trigger will be at, so you can get an alert for it through Grafana.
Cool. So Derek has a question that if we currently have a cluster with tier storage, and over time usage increases, requiring a cluster expansion with all flash nodes. So we do not currently support the ability to add a single flash node to a hybrid. So you have to add hybrid to hybrid, flash to flash. You can mix and match node capacity types. So you can have a cluster that if you have a cluster of older models of a hybrid node, hybrid again being SSD and HDD, you can add a newer model that is in the same sort of tier capacity. Even though we can do some pretty wild mix and match, like tiny nodes or big nodes, but really it's not going to be efficient for you in the long run. So you want to tend to add nodes that are roughly in the same capacity type. But the overall SSD capacity of the cluster will go up. And as you start adding nodes of a newer type with NVMe drives, then the overall performance of the cluster will also go up because you have more SSDs. So, but it's not a thing that you can add. You can't really add a single all flash node to a cluster that has hybrid node types. So normally if the pattern is really outside of what a hybrid cluster should be using, like you have massive file counts of tiny files as a classic example, or you want the absolute peak in performance, you really should be looking at all flash cluster period, and then maybe that's going to be the way for that. Now I can go into details of how tiering works on Qumulo to begin with, but it's really going to be outside of the scope of the 2 minutes that I have left. So please feel free to hit me up on Slack or just email me at joe@qumulo.com, and I'll be glad to set up a session in the future to go over how tiering works and all that. Hopefully that answers your question. Cool. Is any more questions? If not, if anyone has any other questions, you can pop them in the Q&A. We've still got about a minute left. I can do a speed answer. If not, well, thank you for attending. We will make this presentation recording available for you. And as always, feel free to drop into the customer channel and let us know if you have other topics that you're interested in. And thank you for attending today. See you guys online.